All right, last video. We know some things. Let's see how we can apply it in this real life situation. We've got Corey. Corey has a stamp in the shape of a parallelogram. So what Corey is doing is Corey stamps the parallelogram stamp on the front of a poster that he's making. So here's the parallelogram stamp. Here he is stamping it. How many times will the stamp need to be applied to make a row 60 centimeters wide along the dashed line? So Corey drew a dashed line, and then he wants to know how many of these parallelograms can he kind of fit side by side. He wants to see how many will fit within 60 centimeters. So why don't we take a look at that parallelogram. Let's redraw it, just kind of remove it from the picture, maybe draw it a little bit bigger, and figure out some things about this parallelogram. Here we have A, B, C, D. I'm going to go ahead and draw on the diagonals, and those diagonals meet at X in the middle. So not a perfect replication of the parallelogram, but you get the idea. All right, so what do we know? We know that from here at point C down a vertical distance where it's lining up with D is 4 centimeters. So if we just transfer that over to the parallelogram, that's from X to D. So we know that from X to D is 4 centimeters. Well, because we have diagonals that bisect each other in a parallelogram, if XD is 4 centimeters, that means that XB is also 4 centimeters. All right, so BX is equal to 4. I think we're going to need that in a minute. All right, if we go back to the picture, we can also see that from A to B, that horizontal distance is equal to 1.5 times whatever BX is. Well, we just figured out what BX is. So if we just kind of look at what they're saying, they said segment AX is equal to 1.5 times segment BX. And because diagonals bisect each other, we know that BX is equal to 4. So let's just replace the BX with 4. 1.5 times 4. And when we do 1.5 times 4, we get a 6. So we know that AX is equal to 6. Well, because the diagonals bisect each other, that means that CX is also equal to 6. This is what we care about. We wanted this horizontal distance of our parallelogram stamp. AC, the whole thing, is 12 units long. So this is 12 units long. The question is, how many of those parallelograms that are 12 units long can we fit in our picture? Well, the total horizontal distance we're trying to cover is 60 centimeters. So if we take the 60 centimeters and divide it by essentially what would be like the width of our stamp, divide it by 12, let's see how many fit in. 60 divided by 12 is 5. So we can make the conclusion that, let me get my pen, Corey will need to stamp the design five times to make a row 60 centimeters wide.